Hello, welcome to my channel. I'm Ruben, I'm a math teacher. In today's video, we're going to see how we can graph a linear function without using a table of values. How are we going to do this video? Let's look at two examples where we can clearly observe that the value of x in the first instance is positive and in the second example it's negative. We'll then analyze precisely what kind of modification this brings to the linear function. Of course, for this video, we're going to proceed without using a table of values. Instead, we'll be utilizing the fundamental concepts of slope and the y-intercept. Alright, before we actually begin to construct the graphs, what we're going to do first is to clarify some very basic essential concepts. For instance, it's important to remember that the graphical representation of any linear function will invariably be a straight line. So, it can either be a straight line that goes upwards, which we will then refer to as an increasing function, or it could be a straight line that heads downwards, and that will be known as a decreasing function. Now, what exactly is going to determine this for us? The slope of the function. The general form for writing a linear function is expressed as y equals mx plus b, where the slope will always be the numerical coefficient that accompanies the x variable. And the number that doesn't have an x is what we call the y-intercept. And what exactly is the y-intercept? It's the specific point where the function makes contact with the y-axis. So, if we want to accurately graph a linear function, we're going to make use of both the y-intercept and the slope. Why is that? Because by marking just two distinct points, we will be able to accurately draw a straight line. However, before we delve into our very first example, it's absolutely crucial that we always remember to express the slope in the form of a fraction, without exception, alright? For instance, let's represent it as a divided by c. We're going to use the letter c here because, as you can clearly see, we've already utilized it for the y-intercept. Ix plus b. Why am I doing this, you ask? Well, because with this, I'm going to give you the exact steps you need to be able to graph any linear function. Just observe closely how we're going to do it. Alright, let's dive into our very first example where I'll show you the technique to graph a linear function without needing a table of values. The very first thing we're going to do is to locate the y-intercept, which is essentially the number that doesn't have an x variable attached to it. Now, in our specific example here, the y-intercept is -3. We always have to keep the sign in mind, okay? So, this is the very first step, and what exactly are we going to do with that -3? We are going to place it on the y-axis. Since it is -3, it will be located at -1, -2, -3. What did we say today? The slope needs to be written in the form of a fraction. Notice that here you have a 2, but we already know that if there's nothing, if there isn't any number in the denominator, we know there is what? There's a 1. So, now we're going to write the slope in the form of a fraction. And why is that? To carry out the second step. What will this second step be? We're going to move away from the initial point we established, which was the y-intercept by as many units or positions as the denominator value specifies towards the right-hand side. Understood? This particular action represents our second procedural step. This means if I'm standing right here, I'll move 1 unit, because that's what's indicated in the denominator, to the right. This means I'll now be positioned on this specific part of the graph. So what are we going to do next? We're going to move according to what the numerator of the slope indicates. In this case, the 2, right? This will be our third step. And what are you going to do here? It's very easy. If your slope is positive, you're going to move up the number of units indicated by the numerator. If it's negative, you're going to make it go downwards, right? In this case, since it's positive, we're going to move how many units? 2 units upwards, okay? That is to say, from the last point that we marked, the orange one, we go 1 and then 2. And right there, we've established our final point. Now, what's the final thing that we need to do? We simply need to connect the very first point, which is our y-intercept, with the absolute last point of the entire sequence that we have created today. So, what I mean to say is our linear function is going to be plotted in this particular way, okay? And this will be equal to 2x minus 3. Therefore, the function is indeed increasing. And from this, we must draw a very important conclusion. If the slope is positive, then the function will always be increasing. Now let's proceed to see what happens when the slope is negative and how we graph it. Before we move on to the second example, where the slope is negative, I'd like to ask you, if you're finding this video helpful, please give it a like. I also invite you to subscribe to the channel. It would truly help me out a lot. And finally, if you would like to make a collaboration or perhaps a donation to this educational project that I have decided to create, which is not yet monetized, I will leave the corresponding links for you in the description of this video. Any contribution you wish to make is of tremendous help. Now then, let's move on to the second example. You see? Alright, let's move on to the second example, in which we can clearly observe that the slope is indeed negative. We are going to proceed by doing exactly the same thing as we did previously. For our very first step, just as we indicated here earlier, we will need to carefully locate the y-intercept, always keeping its sign clearly in mind. In this specific case, it's positive 1. Alright then, so where exactly are we going to place it? On the y-axis, we're going to mark the value of positive 1. It's going to be located right here in this particular section of the graph. For the second step, what exactly is it that I'm going to do now? Given that it's already presented to us in the form of a fraction, I'm going to take what the denominator is specifically telling me. In this particular instance, the value is 3, and I am going to proceed by moving, as it clearly indicates right here for us, towards the right hand side, 3 distinct places, or 3 full units, starting from the precise point that I had marked earlier today. 1, 2, and 3. Yeah, I'm standing right here. Now what are we going to do? We're going to move 2 spaces in the direction where you'll notice that the sign is negative. If the sign is negative, instead of moving upwards like we did earlier today, we're going to move downwards. By how much? 2 units. In other words, I'll have 1 point and then I'll have the other unit. Finally, what exactly am I going to do? I'm going to connect the very first point with the very last one. What I mean to say is that by taking these 2 points and connecting them, we then have the mathematical function where y is equal to negative 2/3 of x plus 1. A key conclusion to draw from this is that if your slope is negative, you'll notice the function is moving downwards, which means it's decreasing. I hope this video has been helpful. If so, please give it a thumbs up. I invite you to subscribe to the channel. We'll see you in future videos. Cheers!